we can draw the given circuit diagram here. We can draw the given circuit diagram. That means there are 5 resistors. And here we are drawing the circuit diagram as according to the question, or as according to the given diagram. We can draw the diagram again. So these are the 4 resistors, and 5th resistor is connected in this way. Now this circuit or this loop is connected to an electric cell and external resistance. This is the given circuit diagram. Name of the loop is ABCDA. Name of the loop is ABCDA, and the values of different resistors are 10 ohm, then 5 ohm. The middle resistance is 5 ohm, then 5 ohm on the left hand side, and on the right hand side is again 10 ohm. And the resistor which is connected to the electric cell of EMF equal 10 volt is 10 ohm. So this is the circuit diagram. This is the circuit diagram or given circuit diagram, and I1 plus I2 is the current which is generated from the electric cell of EMF 10 volt. I2 is the current which is flowing through 5 ohm from the point A. I1 is the current flowing through 10 ohm resistor from the point A. As the current I3 flows through 5 ohm resistor, remaining current I1 minus I3 is flowing through the 5 ohm resistor between B and C, and between D and C a current I2 plus I3 is flowing through 10 ohm resistor. In this way, I1 plus I2 is the current which returns to the electric cell of EMF equal 10 volt. We have to find the values of different currents, that is I1 equal question mark, I2 equal question mark, I3 equal question mark, and also you have to find the values of current flowing through different resistors. Here we can give the name of the resistors, that is P equal 10 ohm, Q equal 5 ohm, then on the left hand side R equal 5 ohm, and on the right hand side between D and C S equal 10 ohm. We can check the value of P by Q. P by Q equal 10 by 5, which is 2. Now if we divide R by S, then we get 5 divided by 10, that is equal to 1 by 2. P by Q equal 2 and R by S equal 1 by 2. Here P by Q, as P by Q is not equal R by S, Wheatstone Bridge Principle, as P by Q is not equal R by S, so Wheatstone Bridge Principle cannot be used. Wheatstone Bridge Principle is not used or is not applicable for this case. As P by Q is not equal R by S, Wheatstone Bridge Principle is not applicable. Now you have to use Kirchhoff's voltage law to find the values of currents flowing through different resistors and here we have 3 unknown currents, mainly I1, I2, I3. That's why you have to use Kirchhoff's voltage law in 3 different closed loops. Here using Kirchhoff's voltage law in the closed loop ABDA. In the closed loop ABDA, we get, using Kirchhoff's voltage law in the closed loop ABDA, we get 10 I1 plus 5 I3 minus 5 I2 equal 0. We are traveling along ABDA through the 10 ohm resistor. Current I1 is flowing from A to B, and we are also traveling along AB. That's why 10 I1 tends to plus 10 I1. Now if we consider the potential difference across 5 ohm resistors, that 5 I3 will be equal to 5 I3, and across the resistor R equal 5 ohm, we are traveling from D to A, and current I2 is flowing in the opposite direction, and we are traveling along DA, and current I2 is flowing in the opposite direction. That's why 5 I2, that means potential difference across 5 ohm resistor, will be negative. That's why in this case, in the equation, we have assumed 5 I2 as negative. We have assumed 5 I2 as negative. So using Kirchhoff's voltage law in the closed loop ABDA, we get 10 I1 plus 5 I3 minus 5 I2 will be equal to 0, or 2 I1 plus I3 minus I2 equal 0. Again using Kirchhoff's voltage law, Kirchhoff's voltage law in the closed loop BCDB, using Kirchhoff's voltage law or KVL in the closed loop BCDB, we get the last loop was ABDA, but here we have to use Kirchhoff's voltage law. In the second closed loop BCDB, we get I1 minus I3 into 5. That means potential difference across the resistor or resistance Q equal 5 ohm is 5 into I1 minus I3. Then the potential difference across 10 ohm resistor between D and C is 10 into I2 plus I3, and here 10 into I2 plus I3 is negative, and potential difference across the 5 ohm resistor between B and D is also negative. Here potential difference across the 10 ohm resistor between D and C is what? 10 I2 plus I3. That will be negative because we are traveling along BCDBA. That means we have to travel from C to D, but the current I2 plus I3 is flowing in the opposite direction. We are traveling along BCDB. That's why 10 I2 plus I3 is negative. So we get 5I1 minus 10I2. 5I1 minus 10I2 will be equal to 5I1 minus 10I2 minus 20I3 will be equal 0. Or I1 minus 2I2 minus 4I3 is equal 0. We get I1 minus 2I2 minus 4I3 will be equal 0 using Kirchhoff's voltage law in the closed loop BCDBA. Again using Kirchhoff's voltage law, again we have to use Kirchhoff's voltage law in 3 different closed loop here and here. That's why using Kirchhoff's voltage law, that means KVL in the closed loop, in the external loop, that is ABCEA containing the cell of EMF E, we get, that means we are traveling along this direction, that means along ABCEA. Here we have to cross the electric cell. Here first we get 10I2 plus 10I2, then plus I1 minus I2 into 5 or plus 5I1 minus I2, then minus E. And what about the potential difference across 10 ohm resistor? And they will be equal 0. In here E will be minus E, and 10 into I1 plus I2 will be plus. So we get 10 I1 plus 5 I1 minus I3 minus E plus 10 I1 plus I2 will be equal 0. Finally we get 25 I1 plus 10 I2 minus 5 I3 will be equal 10. Or 5 I1 plus 2 I2 minus I3 equal 2. 5 I1 plus 2 I2 minus I3 equal 2. We get 5 I1 plus 2 I2 minus I3 equal 2. Therefore I3 equal 5 I1 plus 2 I2 minus 2. I3 equal 5 I1 plus 2 I2 minus 2, which is equation 3. I3 equal 5 I1 plus 2 I2 minus 2 equal, which is equation 3. Putting the expression of the current I3 from equation 3, in equation 1 we get, putting the expression of I3 from equation 3 in equation 1, we get 2I1. Equation 1 was 2I1 plus I3 minus I2 equal 0. 2I1 plus 5I1 plus 2I2 minus 2 minus I2 equals 0, putting the expression of I3. Finally we get 7I1 plus I2. 7I1 plus I2 will be equal to 2. 7I1 plus I2 will be equal to 2. Or comma I1 minus 2I2 minus 4 bracket open 5I1 plus 2I2 minus 2 will be equal 0. Or comma 2 or comma what we can write I1 minus 2I2 minus 20I1 minus 8I2 plus 8 equal 0. If we simplify, we get minus 90I1 minus 10I2 plus 8 equals 0, or 19I1 plus 10I2 is equal 8. 19I1 plus 10I2 is equal 8, which is equation 5. Putting the expression of I3 from equation 3 in equation 2, we get 19I1 plus 10I2 equal 8. And doing what? Multiplying equation 4 by 10 and subtracting this. Now multiplying equation 4 by 10 and subtracting equation 5 from equation 4 multiplied by 10, we get 10 under bracket 7I1 plus I2 minus bracket open 19I1 plus 10I2 equal 20 minus 8, or comma 70I1 plus 10I2 minus 19 minus 10I2 equal 12, or comma 51I1 equal 12, that is 17I1 equal 4. Therefore I1 equal 4 by 17 ampere. I1 equal 4 by 17 ampere, that is one of the answer. And we get the value of current flowing through the 10 ohm resistor, that is I1 equal 4 by 17 ampere. From equation 4, 7I1 plus I2 equal 2. 7I1 plus I2 equal 2, or comma 7 under bracket 4 by 17 plus I2 equal 2. Therefore I2 equal 2 minus 28 by 17. Therefore I2 will be equal 6 by 17 ampere. I2 will be equal 6 by 17 ampere. I2 will be equal 6 by 17 ampere. That means I2 equal 34 minus 28 by 17. Therefore I2 equal 6 by 17 ampere. That is the current flowing through the 5 ohm resistor between the 2 points A and D. We get the value of current I2 flowing through 5 ohm resistor, which is equal to 6 by 17 ampere, and current flowing through 10 ohm resistors between A and B is found as I1 equal 4 by 17 ampere. And now I3 equal 5I1 plus 2I2 minus 2. I3 is equal 5I1 plus 2I2 minus 2. So putting the values 5 into 4 by 17 plus 2 into 6 by 17 minus 2 equal 20 plus 12 minus 34 whole divided by 17. Therefore I3 is equal minus 2 by 17 ampere. I3 is equal to minus 2 by 17 ampere, that is one of the current, and here current I3 flowing through 5 ohm resistors between B and D is negative, minus 2 by 17 ampere. That's why actually this current I3 will be flowing in the opposite direction through the 5 ohm resistors between B and D. I3 will be flowing from D to B, but we have assumed I3 which flows from B to D. I3 equal minus 2 by 17 ampere, and that I3 is actually flowing from D to B, but we have assumed current flows from B to D. Now I1 minus I3 equal 4 by 17 minus 2 minus bracket open minus 2 by 17. So we get I1 minus I3 which will be equal to 6 by 17 ampere. Similarly we can find I2 plus I3, that will be what? 6 by 17 minus 2 by 17, that means we get I2 plus I3, which will be equal to 4 by 17 ampere. 4 by 17 ampere. And this is the current. I2 plus I3 is the current flowing through 10 ohm resistor between D and C. And I1 minus I3 is the amount of current which will be flowing through the resistor 5 ohm resistor, and we get I1 plus I2 as 4 by 17 plus 6 by 17, that is I1 plus I2 will be equal to 10 by 17 ampere. I1 by I2 will be equal to 10 by 17 ampere. So in this way we can find the values of currents flowing through all the resistance in the given circuit.